Hello, future scientists. Today let's discover HPLC, high-performance liquid chromatography. Think of HPLC as a super-powered sorting machine for tiny things, like separating candies by color. But for chemicals, it's essential in science, especially for making sure medicines are safe and effective. HPLC is used everywhere, in pharmaceuticals, food safety, environmental science, and even forensics. The main idea? Separation. By splitting mixtures into parts, we can identify and measure each one. HPLC is like a detective's magnifying glass for chemicals. Here's how it works. A liquid, the mobile phase, flows through a tube packed with special material, the stationary phase. When we inject a sample, its components race through. Some move fast, some slow, depending on what they stick to. High pressure pushes the liquid through tiny particles, making the process fast and precise. This lets us separate even very similar molecules. For pharmacy students, HPLC is a fundamental tool for ensuring medicine quality. Ready to see how it all works? Let's dive in. Scene transition. An HPLC system is like a superhero team. Each part has a crucial job. The pump is the heart pushing the mobile phase through at high, steady pressure. Next, the injector adds a precise amount of sample into the flow, starting the race. The column is the racetrack packed with stationary phase where separation happens. Components interact differently with the stationary phase traveling at different speeds. The detector is the finish line camera spotting each separated component as it exits. It sends signals to a computer, creating a graph for analysis. Each part must work perfectly for accurate results. That's the HPLC team in action. The mobile phase is more than a carrier. It's key to separation. It's usually a mix of solvents like water and methanol or acetonitrile. The right mix helps components move at different speeds through the column. Scientists adjust the mobile phase's polarity to control separation. It must also be compatible with the column and detector. There are two main ways to run it: isocratic, same composition throughout, and gradient, changing composition. Isocratic is simple and good for similar components. Gradient elution gradually changes the mix, helping separate complex mixtures. This flexibility lets us handle a wide range of samples. Choosing the right mobile phase is crucial for great results. The column is the heart of separation, and there are different types for different jobs. The most common is the C18 reversed phase column, great for separating many drugs and organics. Here, polar molecules move quickly, non-polar ones move slowly. For the opposite, we use normal phase columns with polar silica and non-polar mobile phases. Ion exchange columns separate charged molecules, useful for proteins and nucleic acids. Size exclusion columns separate by size. Big molecules come out first, small ones last. Each column type solves a different separation puzzle. Choosing the right one is key to success. That's the magic of HPLC columns. Scene transition. We've explored the HPLC system from pump to detector. Choosing the right mobile phase and column is vital for accurate analysis. A poor choice can mean missed impurities or bad results. Serious for patient safety. A good method gives clear, sharp peaks, showing each component is pure and safe. Every sample is a new puzzle, and your choices are the tools to solve it. Developing these skills takes knowledge and practice. HPLC is essential in pharmaceutical science for ensuring medicine quality. Mastering it means you help keep medicine safe for everyone. By learning HPLC, you're learning the language of chemical separation. That's science at its best. Imagine a busy pharmaceutical lab, where scientists are preparing a new batch of heart medicine. Before the medicine can reach patients, routine HPLC testing is performed to check for safety. Suddenly, the chromatogram shows an unexpected peak, something that shouldn't be there. The scientists act quickly, using HPLC to compare the sample with pure standards and identify the contaminant. Thanks to HPLC, the problem is traced to a faulty ingredient, and the contaminated batch is recalled before anyone is harmed. This real-world rescue shows how HPLC protects lives and keeps our medicine safe.
If you found this video helpful, please subscribe, like, and share it with others who'd benefit. See you in the next video.